Welcome back to my channel. Today we're going to be talking about some derivatives of some of our common functions, and then we are going to look at where they come from. So we're going to be looking at some different graphs and thinking about how these tangent lines would look. So if I can think about the slopes at each of these points, it can kind of look like a different graph. So if I'm looking at sine of x right here, one of the things that I can look at is at 0, our slope is positive, and it is the biggest slope that we can possibly have. So I have a slope right about here that is positive. So every time I go over, I go up the same amount. So this looks like a slope of positive 1. When I get right here at the maximum, we are going to have a slope of 0. And then we hit this 0 again on the other side of our graph, but this time it's going downwards. So this is giving us a negative slope. I hit our minimum, giving us a slope of 0 again, and we go back to where we started. So if I think about what this would look like if I plotted it, a slope of 1, meaning at 0 our slope is 1, would bring us over here. At the same spot we have a slope of 0. Then we have a slope of negative 1, a slope of 0 again, and then we're back to 1. And if I were to put these together, this is going to look something like this. That was a really bad line. But it's going to look something like this. And if I were to keep going and doing this over and over again, this is going to look like cosine, which is why our derivative of sine is cosine. Similarly, when we look at cosine, we have a slope of 0, a slope of negative 1, another slope of 0, positive 1, and 0. So if I were to plot these, a slope of 0, a slope of negative 1, a slope of 0 again, positive 1, and back to 0. And this one's interesting because we want it to be sine, and it is sine, but sine normally starts middle and goes upwards. This time we're going middle and going downwards, which is why it most resembles negative sine. Exponentials are actually one of my favorite. E to the x is my all-time favorite. And when we're looking at this function, one of the things that we notice is that it's not very, the slope is not very big when we get to negative numbers. But as we go through these positive numbers, our slope is growing bigger and bigger. And this leads us to the phrase, it grows exponentially. So if I were to map out these slopes, they would literally be on the same line. And so e to the x being e to the x is just one of my favorite things ever. And lastly here we have natural log. So natural log is kind of interesting. When we look at this, our slopes are positive. They're getting a little bit more positive. They started out more positive than as they go on later. And eventually they bottom out. So they have kind of like an end to it. So when I look at this, the one that resembles it the most is the positive x values of 1 over x. And that's kind of how we get our derivative for this one. So we have our basic derivative rules. So the derivative of sine, cosine. The derivative of cosine is negative sine. And then we have e to the x. So the derivative of e to the x is exactly what it is. And the derivative of our natural log is 1 over x. So the next thing that we need to talk about is when it's not an exponential e or not a log base b. So for log base b, what we are going to find out is that 1 over x is still in our problem. So 1 over x still shows up, but the other thing in our denominator is going to be the natural log of whatever our value is, whatever our base is, in this case b. When we do our natural log, this ends up going away because natural log is the same thing as saying log base e of x. And if I were to simplify 1 over x natural log of e, natural log and e cancel each other out. They create a 1, and it's because they're inverses of each other. So we can kind of just get rid of it and we ignore it, which is why we get 1 over x. Okay, now on the other hand, when we look at the derivative of b to the x, so b to the x is just like e to the x, where we are going to have that same kind of thing in our problem. So we're going to have b to the x show up in our problem again. Then, just like our natural log, when we multiply it by the natural log of whatever our base is. This has to do with our change of base formula when we kind of look at different things with logarithms and exponentials, and there is a way to kind of look through all of this, but just like everything else in the AP test, just doing it is always, or just knowing it is always easier. So just like the other one, if I were to have this as e to the x, it would be e to the x natural log of e. Natural log and e make 1, so it's just e to the x. So we're going to be practicing these formulas. We really just need these so that way we can learn product rule and quotient rule next time.